Okay, so here's that side example I was talking about. I did this in the video, but it got cut off somehow. Um, so here's a note. We do not distribute functions. Side example says we can, just proving that out, m of 2 minus m of -1 does not equal m of 2 minus -1. So I've just plugged the values in. You could do that yourself. I end up with -1/2 for this left-hand side. And if I were to calculate this out, just take the difference of those two numbers and pop that in as m of 3, I definitely don't get the same answer. I get 3 over -2, which is not equal to -1/2. So do not distribute functions. It's kind of similar to how people want to distribute exponents, sort of, when they have a binomial raised, like squared or something. We don't do that. Also, we don't distribute over multiplication. We only distribute over addition or subtraction, things that look like, if we have like a times b plus c, then we distribute that equals ab plus ac. But other things we just don't distribute like that. So now I'm going to go to page 2 and work some things. This part, this is a little more complicated in the middle here. So I actually think I will go through it, but we might want to talk about some of these in class. I think it's a great review of some messy math with rational expressions and the working with the complex rationals. But again, this is kind of optional. Part 2 is not too complicated, so I think that one, if you want to work on your own and try to figure stuff out, that's totally cool, and you can just check that out. So I might just jot the answers off to the side here for you. So for part 2a, the answer will be -1 for the first one, then 21 2/3, -2, 6, and -5/2. So if you want to just try those, go for it and ask about anything in class. I am going to go back up here and work these out, but it might come out kind of longer than you need to worry about or more complicated. So and one thing we can do too is not have to simplify everything down by multiplying it all out, so that helps. So we're just going to think about, again, what our domain is and stuff. I'm going to rewrite the functions here at the top of the page so we have them down. So m of x was equal to 3 over x minus 5. And remember, x couldn't equal 5 for the domain. P of x is equal to x minus 2 over x minus or x plus 3. Get that right. Comma x not equal to -3. So a lot of times we just put a little comma and put our domain off to the right to designate that. So this first one reads p minus m of x. So that's the same as p of x minus m of x. And we would just go ahead and pop in what we have for p of x is x minus 2 over x plus 3. This time we're not plugging any numbers in, we're just kind of keeping it in its generic form there. And m of x is 3 over x minus 5. And we can actually just leave it like that, except our domain is going to be different because we are going to have to write here x not equal to -3 and x not equal to 5. Make sure you have an and, not an or. in there. So that would be the answer. You can leave it like that. If you were asked to simplify and subtract this expression, that's something we can review in class together. I think that just gets a little messy here. M times P of X, that one would be the same as M of X times P of X. And again, we can just kind of write those next to each other. 3 over X minus 5, and then times X minus 2 over X plus 3. Now this, we can actually distribute the 3 to the X and the minus 2. Clean that up a little bit. So we would have 3x minus 6. The bottom, you could expand that out, but I'm not going to require you to do that here. So x minus 5, x plus 3. And now that it's factored, we have to check our new function and make sure it fits the domain. And that would say x cannot equal negative 3. And x cannot equal 5, which is the same as what we had prior. So it has to fit the M domain, the P domain, and the new function domain on these ones. When you do composition, it's a little different. You have to fit the inner function and the new function, not the both of the functions, but you'll learn that in pre-calc. So M divided by P of X, that one will look like this, M of X over P of X, and then just go ahead and plug in and simplify. And this one's pretty easy to do, as just multiply by the reciprocal, and then we'll distribute the top here. We get 3x plus 9 in the numerator, all divided by x plus 5 over x minus 2. So now that we flip that second fraction around, we have a new situation with an undefined denominator if we had 2 in there. So we have to add that into our domain. So the domain for this one would be x can't equal actually can't equal, that should be a minus there. I don't know why I wrote a plus, so let's fix that. X minus 5 just from here stays the same, didn't become plus. X can't equal 5, and x cannot equal 2. That's our new one. But also don't forget the original x cannot equal negative 3. But that's because we are doing the, the add, subtract, multiply, and divide, that we have to consider both original functions. When we do composition, it's different. So I might show you that in class a little bit. We need to make sure we start with a defined situation and end with a defined situation. But whatever the outer function is, we don't need to worry about. So I'll kind of, if you take me for pre-calc, I'll bring that up again. But the answer for this one is right here. So you always have to have your domain present as well. Like I said, I gave you the answers for this, so maybe you've tried it, maybe not, but we would have we have this chart here. Let f and g be the functions defined by the following table. So again, don't try to go off the table. So f minus g of 3 would be f of 3 minus g of 3, and we use the table. So this is good review here of just finding values on a table for functions. So if I find 3, that's my input is 3. My output is 1 for f of 3. If I have a 3, my g output would be 2. So it's different. And that gives me negative 1 for my answer. f times g of 6, I'd have to find the 6 for my x value. The f of x output is going to be 7. The g of x output is right here at 3. So my answer is 21. So you notice I'm kind of skipping writing out all the separate things. I think you've probably got that by now. Now this one, g of f of g divided by f, all of 1. We're going to find 1 on the table, and then our g function is what goes in the numerator. So 4 divided by our f function is the 6, and then reduce it to 2/3. F of 3 minus f of 2. That one's just split up for us already. So we're going to go look up here at f, the 3. And what's our output for that would be 1. Minus the 2, f of 2, we have to find our output is 3. So we're going to get -2. Now this is kind of what I was talking about on that side note. We have f of 3 minus 2. Now that's a thing you can have, but is it going to equal what I just did? F of 3 minus f of 2. Based on what I just told you earlier, you should say no. So we are going to prove that out. So f of 3 minus 2 would be the same as f of 1. And f of 1 actually leads us to an output of 6. So notice not equal, right? Then lastly, we have f of 3 minus f of 1. We already figured out f of 3 is 1. Right here. F of 1 is 6. We already can use what we figured out, all divided by 2. Notice this is your average rate of change because the 2 represents 3 minus 1, right? Those difference in the x's. Get used to doing that. So a lot of times it's computed out for you. So 1 minus 6 gives us -5 over the 2. So -5/2.